Finishing up 3.3 Earthquake Shaking. The direction that the rupture moves along the fault influences the shaking too. The path of greatest rupture can intensify shaking, which is called directivity. Supershear is an extreme form of directivity. It occurs when the propagation of rupture is faster than the velocity of shear waves or surface waves produced by the rupture. It can produce shock waves that produce strong ground motion along the fault and may significantly increase the damage from a large earthquake. It is most likely to occur along long greater than 100-kilometer straight strike-slip faults. It's kind of like a sonic boom, but for seismic waves in the earth. Local geologic conditions also affect the shaking from an earthquake. Different ground materials are affected by earthquakes in different ways, mainly due to the degree of consolidation, as depicted in this image. Seismic waves move faster through consolidated bedrock, such as hard igneous rock, and move slower through unconsolidated sediment, such as alluvium. But they move slowest through unconsolidated materials with high water content, such as mud and silt by a lake. As the waves move slower, more energy is directed to vertical motion, increasing shaking. This phenomenon is called material amplification. A tragic example of material amplification is the 1985 Michoacan earthquake, moment magnitude 8. The epicenter was located off the Mexican Pacific coast, more than 350 kilometers away from Mexico City. However, the unconsolidated sediment amplified shaking and many buildings collapsed. 10,000 to 40,000 people were killed. About 3 to 4 billion US dollars in damages. 3.4 Geographic regions at risk from earthquakes. As seen previously, near plate boundaries there is an increased risk of the earthquake hazard. This picture shows the seismic hazard in the United States, with areas with the highest hazard marked in red and the lowest hazard marked in light gray blue. Our general area of highest risk is along plate boundaries on the west coast. Along California's coast is strike-slip faulting along the transform plate boundary. In the Intermountain West is extensional normal faulting causing mostly moderate earthquakes. Subduction zones at convergent plate boundaries are the site of the largest earthquakes, sometimes called megathrust earthquakes, with high magnitudes. Areas that have the potential to experience future megathrust earthquakes are Cascade Mountains, Aleutian Islands, and Chile, which has a convergence of about 70 millimeters per year. I'm sure you also noticed intraplate earthquakes that are not at plate boundaries. The New Madrid seismic zone is located near St. Louis, Missouri. It has had historic earthquakes similar in magnitude to West Coast quakes, with magnitudes greater than 7.5. However, the earthquakes are often smaller than plate boundary quakes, but can cause considerable damage due to lack of preparedness and because they travel greater distances. The seismic waves travel greater distances through stronger continental rocks. 3.5 Effects of earthquakes and linkages with other natural hazards. What might be some effects of earthquakes? Pause and make a list. Can you list at least 10 effects? These are the effects we will discuss: ground rupture, shaking, liquefaction, regional changes in land elevation, landslides, fires, disease, and tsunamis. Ground rupture is due to displacement along the fault, causing cracks in surface, called a fault scarp. Shaking causes damage to buildings, bridges, dams, tunnels, pipelines, etc., and is measured as ground acceleration. Buildings may also be damaged due to resonance, which is the matching of vibrational frequencies between ground and building. These images show cracking and displacement from the 1906 San Francisco earthquake. Stanford University, and a badly damaged road in Japan due to an earthquake, as well as bent railway lines. From September 4, 2010, when a 7.1 magnitude earthquake rocked the South Island of New Zealand near Christchurch. Here are some images of fault scarps. A fault scarp produced by the moment magnitude 7.1 Hector-Mine California earthquake, and the Lost River normal fault above Mackay, Idaho in 1987. Note person for scale. The fault rupture occurred in 1983 with a moment magnitude of 6.9. Liquefaction occurs when a near-surface layer of water-saturated clay or sand changes rapidly from solid to a liquid, which causes buildings to float in earth. It's common in moment magnitude 5.5 earthquakes in younger sediments. After shaking stops, ground recompacts and becomes solid. This picture shows some apartment buildings in Niigata, Japan, 1964, after an earthquake with a moment magnitude of 7.5 and resulting liquefaction. Bummer. Sand blowouts, depicted in this image, are another form of liquefaction and are very useful to determine prehistoric ages of fault ruptures. Regional changes in land elevation with either uplift or subsidence can cause substantial damage on coasts and along streams. In this image, show effects from an Alaska's earthquake, March 27, 1964, moment magnitude 9.2. Hinchinbrook Coast Guard Dock, raised above all but the highest tides by regional uplift in Prince William Sound. Land in this area rose about 8 feet during the earthquake. Landslides and avalanches are another common effect of earthquakes. In fact, earthquakes are the most common triggers for landslides in mountainous areas and can cause a great loss of human life, especially where there are steep slopes with structurally weak sediment. This image shows an example from San Salvador, El Salvador, January 2001. Landslides can also block rivers, creating earthquake lakes, one of which is being exploded in this picture, China, 2008. Moment magnitude 7.9, making channel to drain earthquake lake. The dam is not stable, so they are exploding the dam so it does not fail later, causing a catastrophic flash flood. Fires are another common effect of earthquakes, due to ground displacement causing power and gas lines to break and ignite. These fires are hard to put out because water lines are often broken. There is also often toppled, cracked, flammable stuff, gas, power lines, etc., increasing the fire hazard after earthquakes. This image shows the great 1906 San Francisco earthquake, moment magnitude 7, where fire caused comparable damage to the earthquake itself. Disease caused by earthquakes effects is due to a loss of sanitation and housing, contaminated water supplies, broken sewer and water lines, disruption of public health services, and the disturbance of natural environment, such as increased dust and spores in the air that can cause valley fever here in the dry West. Natural service functions of earthquakes. 3.6. What is a natural service function? It's a benefit to an otherwise not so favorable hazard. It's a reason we might want a hazard to occur. What might be some natural service functions of earthquakes? Pause the discussion and see if you can list a few. My list includes water, oil, and natural gas may be trapped by faults. New mineral resources may be exposed. Scenic landscapes may form. And future earthquakes may be reduced due to release of energy. Groundwater, oil, and natural gas often cannot pass through faults due to fault gouge, a fine rock powder created as the rock grinds past each other. So the liquids travel through permeable rock until a fault is reached, and then is trapped and collects in the pore spaces. Later, someone spends a lot of money and installs a well to suck up the valuable liquid. This is depicted in this image. Mineral resources are often deposited along faults. The faults are not permeable to fluids trying to cross the fault. The fault is often very permeable to fluids going along it. Sometimes these fluids deposit minerals generally incompatible with the rock matrix, like gold and silver, along the fault, as depicted in this image from Phoenix Gold Mine in Colorado. Earthquakes along faults can also raise rare earth ore deposited deep in the earth towards the surface where it can be mined. Raising the earth also can make some spectacular scenery, like Grand Teton National Park, seen in this image. Another natural benefit is future earthquake hazard reduction, i.e., if a smaller earthquake happens, then enough stress and strain can't be built up for the big one, right? Makes sense if you think about it.